Good evening, esteemed colleagues, organizers, and fellow researchers. It is with great pleasure that I stand before you today to introduce myself and my esteemed team as we embark on a journey through our research findings. This is Syed Abdul Wasay a student hailing from National Textile University, Karachi, Pakistan, and I am honored to represent a dedicated group of individuals who have been working hard to analyze COVID-19 spread using AI. Before delving into the depths of our research, allow me to introduce my talented colleagues who have been instrumental in bringing this project to fruition. Dr. Danish Hassan and Mr. Usama Raza from National Textile University, Karachi, Pakistan, and Dr. Kashif Javed from Department of Textile and Apparel, UMT Lahore. Together, we have traversed through hours of experimentation, analysis, and collaboration to shed light on the insights from 7 countries data on spread of COVID-19 using AI. These countries include Russia, Pakistan, India, China, USA, France, and South Africa. Today, we are thrilled to share our discoveries, insights, and conclusions with the esteemed gathering. Our journey has been one of curiosity, perseverance, and shared passion for advancing knowledge in our field. As we stand on the precipice of this presentation, we invite you to join us in exploring the intricacies of our research and engaging in meaningful discourse that will enrich our collective understanding. With that said, let us embark on this intellectual odyssey together. As we navigate through the realms of discovery and innovation, thank you for your attention, and we eagerly anticipate the exchange of ideas and insights that lies ahead. Coming towards the outline of the presentation, have abstract, introduction, methodology, research and discussion, acknowledgement, references, and conclusion in the following presentation. Coming towards the abstract. In this study, we leverage artificial intelligence to analyze the COVID-19 pandemic's spread across 7 countries: Pakistan, India, Russia, China, USA, France, and South Africa. Using monthly data from March to September 2020, we employ AI algorithms to fit mathematical models to the selected data, focusing on both affected and death count. Our analysis reveals that a polynomial model consistently provides a significant fit to the time series data from all countries. The high coefficient of determination R2 equals to 1 obtained from these models indicate their strong adequacy in capturing the trends. Notably, Pakistan and India exhibit similar graphical behaviors in both affected and death datasets. Additionally, we integrate fractal dimension techniques to explore the long-term dynamics of COVID-19 spread. The results suggest a continued long-term spread of COVID-19 with observed declining phases in affecting and death time series data across all countries. Our findings imply an anticipated reduction in the spread of COVID-19 in the future, as inferred from the patterns identified, although AI-driven analysis. The historical analysis shows that the origin of SARS-CoV-2 was the Wuhan, China. This new disease has a name of COVID-19 from coronavirus. Global efforts and prevention of the spreading COVID-19 cannot be well understood only by biological and healthcare tools. Some mathematical models have been investigated for further improvements and give estimations for such model parameters. An issue that can be further studied is identifying key critical model parameters. The history of the coronaviruses started from the 1930s when the infectious bronchitis virus (IBV) infection was caused by the domesticated chickens in humans. It was firstly reported in the 1960s to avoid stigmatizing the virus's origins in terms of population, geography, or animal association. The WHO termed as COVID-19 in December 19. This virus involves serious respiratory tract infections. We briefly review the historical evolution of the SARS-CoV-2 to the Earth. In early December, the SARS-CoV-2 appeared in Wuhan, China. The disease caused by the new coronavirus has a name, COVID-19, where CO stands for corona, VI is for virus, and D for disease, and 19 indicates the year, which is 2019. The OMS Director General Tedros Adhanom Ghebreyesus announced it on February 11, 2020 during the extraordinary press conference dedicated to the virus. Continuation on January 9, 2020, the Chinese Center for Disease Prevention and Control (CDC) reported that a new coronavirus initially called 2019 nCoV and now called SARS-CoV-2 has been identified as the causative agent that has been rendered publishes the genomic sequence. Holmes on March 11, 2020 declared that COVID-19 can be defined as a pandemic. The new ordinance of 22 March 2020 issued by the Minister of Health and the Minister of Interior from 22 March people are prohibited from moving with public or private transportation in a municipality other than that in which they are located except for proven work needs, absolute urgency, or for health reasons. Coronaviruses are a large family of viruses causing diseases from the common cold to more serious ones such as Middle Eastern Respiratory Syndrome (MERS) and severe acute respiratory syndrome that is SARS. Coming towards the material and methods, the COVID-19 created a problem for the whole world, and the scientists developed their ideas and analysis on the issue. In this study, we analyzed the COVID-19 dataset by two techniques: fractal dimension for persistency and by fitting used polynomial technique. Different strategies are applied for fractal instrument. We utilized box tailing method for information destruction. The matrix-based procedure continued in box checking strategy. The picture or time arrangement information can be chosen by lattice and tally the number of framework boxes by covering the place of the picture or time arrangement information. By consistently contracting the size of the matrix, the structured example might be captured all the more precisely. This method of fractal measurement appeared in condition where number of boxes speaks to by n and covering the example R is the amplification or the opposite of the containers on diagram the cline of y-axis log n against log R. On x-axis this proportion named by fractal measurement. Formula indicates that d equals to log n over log R. The fractal dimension is a technique that shows the smoothness or roughness of time series. The expression represents the well-defined relation of fractal dimension and Hurst exponent. F plus h equals to 2. The association of f and h in the above expression indicates that higher the value of f, lower will be the h, and vice versa. Usually, self-similarity is measured using some power law. The power demonstrates scaling or similarity dimension. The F show the self-similar object through self-similar places are scaled down using a factor S expressed as. Table 1. The association of F. This table clearly shows the association of F and H with correlation and nature of processes, which is persistent, Brownian, anti-persistent. These values indicate positive, zero, or negative correlation of the both figures. The association of F and H is lasting by representing the correlation and nature of the time series. Then the second technique is the polynomial regression model. It is important that when our data is correlated, but the relationship is not linear, so that depending for this purpose, we can do a polynomial regression of the data. In this study, we found 6-degree polynomial to understand the behavior of COVID-19 data. The general equation of the polynomial is presented below. Polynomial regression is the form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial in x. The general equation for polynomial regression of degree n is given below. Now let's discuss the results and distributions. The monthly time series data of COVID active and death cases of seven selected countries shows that the polynomial model of degree 6 is best fitted. The coefficient of determination r equals to 1 endorsed the adequacy of the model. The similar behavior was observed for active and death cases of Pakistan. Month of June 2020, the peak was observed in active and death cases, depicted in figure 1a. Clearly, both graphs are different, and they show how from 0 to the peak the results can go.